In this video, we are going to continue our discussion on discrete probability distributions, and we are going to be really digging into those, just getting a kind of a standard definition, as well as looking at some of the properties of a discrete probability distribution. All right, so let's start by getting that definition up here. So a discrete probability distribution is all possible values. Right, we could also say all possible outcomes of the discrete random variable along with their associated probabilities. All right, so we've already seen an example of this. Right, in the last video, we looked at. You'll probably need more time to write that down, but we already looked at an example of this when we looked at our experiment being rolling a D4 and kind of recording whatever number is rolled. Right, and we listed all of the possible outcomes for that discrete random variable 1 through 4, right? And we listed their associated probabilities, right? Which was 0.25 for all 4 of them, all right? And so that's all we're trying to do. We're just trying to describe that process, right? What's happening there, and we're doing so by listing outcomes and probabilities. All right, now let's look at a couple of properties. All right, so with these properties, really what they're telling us, if something we're looking at that we think might be a discrete probability distribution, right, if it doesn't meet these 3 properties, or if it doesn't have these 3 properties, then it's not a distribution, right? Not a discrete probability distribution at the very least, right? So these are also things that we just know a discrete probability distribution have, right? And what are going to allow us to do some things later on. Right? These also are going to look pretty familiar from kind of what we saw in the last chapter, in chapter 5, where we looked at our basic laws of probability. Again, those laws apply to any type of probability you're doing, right? So some of these are going to look familiar, right? But the first one is that the sum of all, that's not going to fit, all right? The sum of all probabilities must equal 1. All right, we could also write this out as the sum px equals xi equals 1. All right, so of course, again, just like the last time that we kind of said something like this when we were looking at those laws of probability, this isn't just any random probabilities that have to add up to 1, but the probabilities for a specific kind of thing, right? So if we're looking at that rolling a D4, the probability of all of those results needs to equal 1, and they do, right? 0.25 added up 4 times is going to equal 1, right? So that's what we mean by the probabilities. The sum of the probabilities have to equal 1. All right, second, and yeah, I'm going to try to squeeze this in here. All right, so second, the probability of any value must be between 0 and 1 inclusive. All right, so this is, let's see, we'll just cram this in down here. Might write this up later just so we definitely get it. All right, but all right, again, this is one we also saw the probability of any value must be between 0 and 1, right? Inclusive, so it can be 0, it can be 1, right? Mathematically, we can write that out as 0 less than or equal to the probability x equals xi less than or equal to 1, right? Really, all it's saying is that if you get a probability, or if you're doing a probability calculation and you get a value that is greater than 1 or less than 0, so in other words, a negative number, right, then we need to go back, check our work, because we've done something wrong, right? Because we cannot have probabilities that fall outside of this 0 to 1 range. All right. So this is an important one, all right, especially starting in this chapter, right? We had this in the last chapter, and I told you pretty much the same thing, but I also said it's going to be kind of difficult to do that in this chapter, right? To get a value that's negative or get one that's greater than 1. In this chapter, it's not that hard to do, all right? We're going to be doing some more complicated calculations, right? You're going to do a lot more work on your calculator in this chapter to find these probabilities kind of as we get to them, right? It's going to be very easy to leave a number out, put in the wrong number, not do something correct and get a funky answer, right? And if we remember that probabilities have to be between 0 and 1, that can save us a lot of heartache farther down the line, right? Because if we can spot it, right, hey, this answer's wrong, then we can do something to fix it sooner rather than later. All right, and then the third property is that the probabilities are additive. All right, so what do we mean by this? All right, essentially we're saying, well, let's say we were asking, what's the probability that x equals xi or x equals xj? All right, if this is the case, then we can find that probability by simply adding the probability that x equals xi and the probability that x equals xj. All right, so really what we're essentially doing right here, right, what this is essentially just asking for the probability of the union between xi and xj, right? When we have one of these discrete probability distributions, right, none of the outcomes are going to be all of the outcomes are going to be mutually exclusive, right? So none of them are going to share any common points as far as if we're just looking at that one variable, right? So for example, on rolling in D4, you're going to get either a 3 or a 4. There are going to be no times where you get 3 and 4, right? So since they are mutually exclusive, we can use that sixth law of probability, right, and find the probability of a union by just adding the probabilities together, right? You don't necessarily need to know all of that, right? But that is what's happening here, right? But the big thing is, if we're trying to find the probability of kind of two outcomes, all right, we can just add the probabilities, their individual probabilities together. All right, let's go ahead and take a look at an example of this. All right, or an example of some of these properties. All right, and what we're going to do is we're essentially just going to build another probability distribution. All right, so I'm not going to write a ton of this down other than just the numbers. All right, but here's the scenario. All right, so we're going to say we're looking at Matt. Right, Matt is a lawyer. All right, and over the past couple of months, he has been recording the number of cases that he prepares each day. Right, so at the end of each day, he goes and looks at how many cases he prepared, right, or prepared for, and then he records that. Right? We're going to assume that Matt never starts a case and doesn't finish it. Right? So if he starts working on a case, starts preparing it, he's going to finish it. If he's not going to have time to finish it, he's not going to start it. All right? Just for some simplicity, and then also to make this a discrete probability, all right, or a discrete random variable. All right, so he might have that information kind of looking kind of in this format. All right, he might essentially just have a frequency distribution, right? And we might be given this information here. All right, we're going to kind of move through this a little quickly, right? But let's say that we've got this information and we're trying to describe, the process of how many cases that get done, right? So we want to make our probability distribution. So right now we've just got a frequency distribution. We want a probability distribution, right? So we are going to define our variable, right? So that's the number of cases prepared in a day. All right, then we're going to need to list all of our possible outcomes. Well, luckily we've got those right here in this frequency distribution. So 0, 1, 2, 3, and 4. And then we need to determine the probabilities. All right, so we need to find those probabilities. Now, this is not as cut and dry as the example with rolling a d4, but it is still pretty simple, right? Remember that we can use our relative frequency approach. We've got this frequency stuff, and so we can just find the relative frequency, use those as our probabilities, right? Now, the total number of days, right, or kind of n is 260. So to find these probabilities, we would just take 80, divide by 260, all right, for the probability of x equals 0, so on and so forth, all right? So we're not going to sit here and actually do those, but I'm just going to write down the probabilities. All right. So there is so once again, just another example of putting together a discrete probability distribution, this time using the relative frequency approach rather than what essentially was the classical approach with that D4 example from the last video. Right, so when we look at this, right, we want to make sure that all of our different properties have been met, right? So the first one, right, all the probabilities should add up to 0, right? And in this case, I believe that they do. I haven't checked in a while, but all the last digits add up, so that makes me think it will. One caveat to this, so all the probabilities should add up to 1. Right, so when you've got a probability distribution like this, you add up your probabilities, they should add up to 1. Right? However, as we move forward in this chapter, we are going to be doing some slightly more involved calculations for these probabilities, right? And depending on how you round, right? Sometimes it just happens that it's not going to equal 1, right? You might get it to where it's equal to 0.999 or 1.001, right? If you're that close, that's okay, all right? So especially when you're calculating these yourself, right? When you're putting together these tables, depending on rounding, depending on a couple of other things, you can be off a little bit and still be correct, all right? If I give you a probability distribution, which I am going to do, and I ask you to evaluate it and tell me whether or not it could be an example of a discrete probability distribution, in that case, when I just give it to you, it should equal exactly 1, right? If it doesn't equal exactly 1, we would say, no, it's not a discrete probability distribution, right? But again, when you're actually in practice, when you're actually doing these calculations, right, it can be, you know, a 1,000th off, right, or however you're however many decimal places you take out your answer to, right? But just a little word of warning, right, on that. But here, you know, our first property is met, right? We add these up, they are going to add up to 1. And most of the time, they will add up to 1, all right? Then our second property is that all of our probabilities have to be between 0 and 1, right? And that's true for this example, right? So all of these probabilities are between 0 and 1, all right? We don't have any negative probabilities, right? We also don't have any probabilities that are greater than 1, so we're good on that front. All right, and then third, the probabilities are additive. All right, so this is one that you may not be able to necessarily check, all right? At least not just when you're given this, all right? But these probabilities are additive, and I do want us to look at this because it's also going to give us an opportunity to see how these probability statements are going to look. All right, so let's say that I want to know, right, what is the probability Matt prepares less than 3 cases. All right, so if this is the question I'm asking, all right, then my probability statement is going to look like this. All right, so we're asking what's the probability that the number of cases prepared in a day, so X, so we're going to just slap X in there so we don't have to write that all in. All right, probability that the number of cases prepared in a day is less than 3. All right, so this is the way we're going to be setting up these probability statements. Right, to find that out, we can use the fact that the probabilities are additive, right? And so if we're looking for the probability X is less than 3, well, we just need to know, well, which outcomes fit into that event, essentially, right? Which values are less than 3? Right, well, 0, 1, and 2 are all less than 3, right? And so we would find this probability by adding the probability that X equals 0 plus the probability that X equals 1 plus the probability that X equals 2. All right, so I think probably should. All right, I'm going to erase some of this so we can actually write that out so we can all see what's happening. All right, so again, all right, what is the probability that X is less than 7? That is what or not 7, that's not even on the board. X is less than 3. All right, so to find this answer, we're going to do the probability X equals 0 plus the probability X equals 1 plus the probability X equals 2. All right, so 0.308 plus 0.231 plus 0.192. All right, once we put that all together, the probability X is less than 3 is 0.731. All right, and so that is how we would find one of these probabilities. All right, so that is so that we're going to be heavily relying on the fact that our probabilities are additive for a discrete probability distribution. All right, let's see, was there anything else? Well, if there was, I've forgotten it. So we will call that there. All right, so that is kind of the rundown for a discrete probability distribution. All right, kind of looking at those. Oh, one thing I remembered. All right, kind of the way I might kind of ask you about those, the fact that the property that the probabilities are additive. Right, I might, you might have the distribution. Then I might say the probability, X is less than 3 equals 0.578. Right? Well, if that's the case, right, then these probabilities aren't additive, right? So it's not a discrete probability distribution, right? So essentially, give you a probability, and then you have to check to see if it's correct, all right? But that is, all right, that is finally everything, all right? So again, all right, looked at those. Kind of just what a discrete probability distribution is, looked at those properties, right, then looked at an example and ran through those properties and looked at them in a little bit more detail. All right, in the next video, we're going to start looking at what is known as expected value. All right, so this is going to be, we're just going to start getting a little bit more math heavy, all right, but it's not too bad, all right, but that'll be in the next video, and I will see you then.